You'd think the fastest way to get a package from Memphis to Los Angeles is to fly it directly there. FedEx doesn't do that. Instead, it flies it to Memphis first, the wrong direction, often, before sending it back out. That seems insane. Except the Mongols figured out the exact same wrong direction trick 8 centuries earlier, and it's the reason both systems actually work. This video is about why going the wrong way is sometimes the fastest way to get somewhere. Here's a question worth sitting with for a second. If you had to get an urgent message from New York to Beijing right now, with no phones, no planes, and no roads, just your own 2 feet, how long would it take? And what would go wrong along the way? Think about it honestly. You'd get tired. You'd get lost. You'd run out of food. You might get hurt or robbed, or simply give up somewhere in the middle of a continent you don't recognize. That's the problem this video is really about. Not distance itself, but what distance does to trust. The farther something has to travel, the more chances it has to fail, and the harder it becomes to guarantee it will ever arrive at all. This mattered enormously in the ancient world. An empire that could not move information faster than its enemies could move armies simply would not survive. Genghis Khan understood this. He built a network of relay stations roughly every 20 to 30 miles across his territory, because holding an empire together depended on speed of communication just as much as it depended on soldiers. It still matters today, just with higher stakes. A single delayed shipment can shut down a factory. A missing part can stop a hospital in its tracks. Modern supply chains are built on an assumption that would have sounded impossible a century ago, that a package can reliably cross a continent overnight. The obvious solution, sending one messenger or one vehicle the entire distance, sounds simple. But no horse and no truck can survive that trip alone. So if one horse cannot make a 5,000-mile journey, what can? The Mongols answered this question with something surprisingly simple. Instead of asking a single horse or a single rider to survive an impossible distance, they broke the distance into pieces small enough for any horse to handle. Genghis Khan set up relay stations every 20 to 30 miles along the major routes of the empire. Each one was stocked with fresh horses, hot food, and a place to rest. A rider would arrive exhausted, hand off his message, and the next rider would already be waiting, mounted, ready to go. This is the part people usually miss. The innovation was not a faster horse. There is no such thing as a horse fast enough to cross an empire alone. The innovation was the network itself, a standing chain of resupply points that let speed continue indefinitely, long after any individual horse or rider would have collapsed. By the height of the system, this network included more than 10,000 stations and roughly 300,000 horses, spread across the largest contiguous land empire in history. A messenger could cover somewhere between 200 and 250 miles in a single day, which is faster than mail moved across parts of Europe centuries later, even after the invention of the stagecoach. But speed was only half the design. The Mongols also built in a way to catch failure early. At each station, a clerk recorded the exact time a messenger arrived and the exact time the next one departed. If a gap grew too long, it showed up immediately in the records, and someone could investigate why. This was, in effect, a primitive performance monitoring system, built centuries before anyone had a word for logistics. There was also a warning system built for urgency. A messenger carrying time-sensitive news would wear a belt of bells. The sound announced him before he arrived, so the next station could have a horse saddled and ready the moment he rode in, cutting the handoff down to seconds. Put all of this together, and what you get is not a transportation system in the way we usually think about one. It is an early form of infrastructure design, built entirely around a single insight, that no one part of the system needs to survive the whole journey, as long as the system itself never stops moving. 7 centuries later, a very different traveler was about to stumble onto the exact same insight in an economics classroom, using an idea his professor did not take seriously at all. Now imagine a different problem. Instead of one message crossing one empire, imagine thousands of packages moving between hundreds of cities every single night. The instinct might be to build a direct route between every pair of cities that need to exchange packages, but that idea collapses almost immediately. The number of possible routes explodes far faster than the number of cities. Serving even a modest network this way would require an impossible number of dedicated routes, most of them running half-empty most nights. In 1965, a Yale undergraduate named Fred Smith proposed a different answer in a paper for an economics class. Instead of connecting cities directly to each other, route everything through one central hub first. A few large hubs, fed by many smaller spokes. The professor was not impressed. The story goes that Smith received a C on the paper because the idea seemed impractical. Smith built it anyway. In 1973, he founded Federal Express around exactly this structure. Every plane, no matter where it started, flew first to a central hub in Memphis. Packages were unloaded, sorted, reloaded, and only then flown back out to their actual destinations. This is the moment that seems backward at first glance. A package traveling from, say, Los Angeles to Dallas might fly the opposite direction entirely, toward Memphis, before heading toward its real destination. It looks like wasted distance. It is not. The beginning was rough. On the very first night of operation, 30 aircraft took off, and the entire system delivered only 11 packages. The company lost $27 million in its first 2 years, an enormous sum at the time. This was not an idea that succeeded instantly, even with modern aircraft and modern infrastructure. It took years to prove the model actually worked. But the underlying logic held up. A hub can be placed deliberately for the best possible speed and coordination in a way that no single regional route ever could be. And a hub can absorb an increase in volume far more easily than a web of separate routes ever could, because more volume simply means more efficient sorting at one central point, rather than an ever-growing tangle of new direct connections. FedEx also built its own version of the Mongols' clerks and their handoff logs. Barcode scanning let the company track a package's exact location at every stage of its journey, replacing guesswork with data, the same way a rider's arrival time once told a station exactly where a message stood. Today, FedEx Express alone operates 15 global hubs, and the company moves more than 15 million packages a day. The 300,000 horses of the Mongol Empire have become a fleet of aircraft, but the underlying shape of the system, small units flowing into central points and back out again, has barely changed at all. Strip away the horses. Strip away the aircraft. What is actually left once you remove the technology from both of these systems? What is left is a structure, and it is nearly identical in both cases. Fixed points, spaced out across a territory. Fresh capacity waiting at each point, so that no single unit ever has to survive the entire journey alone. A standardized way of handing something off from one stage to the next, and a method for catching failure early, whether that is a clerk's logbook in a Mongol relay station or a barcode scanner in a Memphis sorting facility. Neither system is really a straight line from one place to another. Both are a network built around central points, with everything routed through them rather than around them. That is the real invention in both cases. Not the horse, and not the airplane. The shape of the network itself. Once you see that shared shape, the similarities start to add up quickly. Both systems replaced one long, fragile journey with many short, reliable ones. Both concentrated resources at specific nodes instead of spreading them thin along an entire route. Both treated monitoring as a core part of the design, not an afterthought bolted on later. And both required an enormous upfront investment that looked questionable at the time, whether that is hundreds of thousands of horses stationed across an empire or a startup airline losing millions of dollars a year before anyone believed the model would work. This is not coincidence. It is what happens when any system tries to solve movement across a large enough distance. Different eras, different tools, but the same underlying mathematics of distance and reliability pushing toward the same answer. The comparison does have limits, though, and it is worth being honest about where it breaks down. The Yam existed to serve the Mongol state. Station upkeep was effectively a tax obligation placed on local populations, and the system's core purpose was military and administrative control. It did carry some merchants, identified by official tablets, but that was a secondary use, not the reason the network existed. FedEx is the opposite in this respect. It is a private company competing in an open market, which means its network had to solve problems the Mongols never had to think about at all. Pricing, customer trust, competition from other carriers. Nobody was forced to use FedEx the way a Mongol subject was obligated to maintain a relay station. The company had to earn every single customer, one shipment at a time. So the same structural solution ended up serving two very different masters, one built on command, the other built on competition. That difference matters, and it is worth sitting with rather than smoothing over. Which brings us to the detail that opened this video. The FedEx plane flying the wrong direction toward Memphis was never a flaw in the system. It was the entire design. Both the Yam and FedEx accepted what looks, on the surface, like inefficiency, a stop at a relay station, a detour to a hub, in exchange for something more valuable, reliability that holds up across an entire network, not just a single route. This is the underlying principle connecting a 13th-century horse network to a modern cargo airline. Spreading resources thin across every possible direct path creates fragility. Concentrating control at a small number of well-chosen points creates resilience, even though it looks, at first glance, like it should slow things down. And this pattern does not stop at horses or packages. Any system that has to move something valuable across distance or across time tends to face this same trade-off. The routing systems that carry information across the internet rely on central nodes rather than direct connections between every device. Large organizations route decisions through management layers rather than letting every individual coordinate directly with everyone else. The technology changes completely from one example to the next. The underlying shape of the solution does not. Reliability at scale is almost never built by making one path faster. It is built by redesigning the entire network around a small number of points that everything else can depend on. So here's the question worth sitting with. If reliability at scale isn't about speed, but about how a network is shaped, where in your own life, your work, or your team are you still trying to solve a distance problem with a straight line, when what you actually need is a hub? Drop your answer in the comments. I want to see what patterns you find.